Okay, this is a newer video I made on graphing quadratic equations. If you look on my channel, there's one that I made um, during the first year for COVID coming back. And it's more focused on graphing points from a table and then identifying the vertex. And I wanted to kind of pull it all together with looking at the different points on a graph of a parabola of a quadratic and tying together all of the different points on there and where we would get those from. So before we fill in the blank on these notes and everything, let's talk a little bit about the graph itself. So if I'm looking at a graph and um, I have the graph of a quadratic, and let's just say that, and y'all, it is so hard to graph using these pencils on a screen. But let's just say I've got this, okay? All right, such as it is shaped kind of like a horseshoe, and it's the shape of a quadratic graph is called a parabola. Okay, you need to know that name. And then we look at which way is it pointing up or it could be pointing down. And you occasionally can see them sideways. But we're really not going to do any of these. So pointing up or down. And remember we talked about yesterday if A, so if we got standard form is ax squared plus bx plus c. All right, so if A is positive, then it's going to be a parabola facing upward. All right, and if it's A is negative, then the parabola is going to be facing downward. All right, and some say a smile or a frown. Okay, so if something's negative, it makes you frown. So parabola is going downward. If something's positive, it makes you happy and makes you smile. So, y'all, if y'all have me in class, you know I'm not that type of person that, let's just say I couldn't teach elementary school. Okay, so you'll rarely hear me say stuff like that. It'll make you smile, it'll make you frown. Okay, I'm getting off the point. The other thing we can tell about the parabola is we're looking for its highest or lowest point. All right, so if it's positive, if A is positive, it's an upward, and you have the lowest point is there. So that would be your minimum, all right? And the lowest point is a minimum, and it's your vertex. When A is negative, then your vertex is going to be your maximum point, your highest point on the parabola, and it's called a maximum vertex. Okay? So if we're looking at this one, our lowest point is the minimum vertex, and this is at 0, -2. Okay? We can also identify some other points. If we look here, we can see that we have our x-intercepts. All right? And another name for x-intercepts when you're graphing a quadratic is called your roots or your solutions, right? So our x-intercept here is negative 2, 0. And then here it's 2, 0. Okay? And if you notice, your x-intercept on your your x-coordinate on your vertex was 0, and then your intercepts are 2 and negative 2. All right, so that ties into what we call our axis of symmetry. Okay? I abbreviate a lot, y'all, I'm sorry. But the axis of symmetry is a imaginary vertical line that splits a parabola in half. So this side of the parabola would be a mirror image of this side of the parabola. Okay? So in saying that, we had 2 and negative 2 were our intercepts, and 0 was our x-coordinate of our vertex. They're the same distance apart. All right, from the axis of symmetry, it's 2 units to our x-intercept. It's 2 units to our x-intercept because each side mirrors the other. All right, so I kind of wanted you to make that connection. Okay. So I also know that these are my solutions, right? So if I have my solutions as 2 and negative 2, then I know my factors would be the opposite. So if I said that my x-intercept was 2 and this was negative 2, if I want to put those set to 0, then I would bring these to the other side. So I'd have x minus 2 equals 0 and x plus 2. So those would be my factors. All right. And if I have my two factors, x minus 2 and x plus 2, I can distribute. And x times that would be 2x, negative 2x, and then negative 2 times 2 is negative 4. So my equation would be x squared, and 2x minus 2x is 0x minus 4. Let's simplify that so I don't need to write the 0x. This would be my equation, y equals x squared minus 4. Okay. Now, I do want to say, let's talk about y-intercept, not our x-intercept, but your y-intercept. To find my y-intercept, I know that on a y-intercept, my x is always 0, right? So if I plug in 0 for x, you get your y-intercept. So if I plug in 0 here, 0 squared minus 4, my y-intercept is negative 4. And if you notice here, it is. So for a quadratic, when it's in standard form, and a is 1, then your c, your constant, is always your y-intercept. Okay? So let's go plug in some notes here. Some things we just discussed. All right. So you can tell the way a parabola will open by looking at A. If A is greater than 0 it opens at the top, so it's opening up. If A is less than 0, it opens at the bottom. All right, so this would be a minimum vertex and a maximum vertex. All right, so when we're graphing, we're going to rewrite the equation in standard form. And we're going to define the variables. We're going to look at A, B, and C, see what those coefficients are. And then we're going to find the vertex. All right, and if you remember from yesterday, our introduction to quadratics, we used the formula h equals negative b over 2a, and k is the function of h. So basically h is the same thing as x, and k is the same thing as y when you're thinking about the coordinates of the vertex. All right, that x and y coordinate that represents the vertex, that ordered pair. All right, once you find out what h is, you can plug it in to find k. So, okay, find the y-intercept by substituting 0 for x, and just know the y-intercept is always c. Find the x-intercepts by solving, and the only method you know right now to solve a quadratic is factoring. We'll get into a couple others next week, like completing the square, using quadratic formula. Sometimes you can use the square root method. All right. Next, when you go to graph, you'll plot the vertex. And then because you know what A is, you're going to know if it's going to open up or down. And then you would just graph your intercepts. Your y-intercept and your x-intercept. And then you'll connect with a smooth, hopefully, unless you're Miss Lane, a smooth curve. Connect the points. Okay? All right. So let's go down and let's look at number 2. All right, so for this one, all right, we've got it in standard form. You got your x squared, your x, and then your constant. So we know we're going to define our variables. A is negative 1/2. B is 2. And always make sure you look at the signs in front of a number. All right, and C is negative 4. All right, and I know that C is my y-intercept, so it's negative 4. All right, so let me fill those in the space. All right, so I can automatically do this with C. And then we're going to find H and K, or X and Y of our vertex. So to find the X, or the H, and don't get hung up on H and K and X and Y. When it's in vertex form, they call them H and K. Also in Algebra 2, when you're dealing with circles, you're going to be calling them H and K. Okay? But for quadratic, when you have it in vertex form, H and K are your vertex. All right? So, to find my H, the formula was opposite of B over 2A. Sorry about that, I am in school. All right, so the opposite of B, so the opposite of 2 would be negative 2 divided by 2 times A. A is negative 1/2. All right, so that's going to be negative 2 divided by 2 times negative 1/2 is negative 1. So So negative divided by negative is positive. All right, so my x-coordinate of my vertex is going to be -2. So now I need to find my k or my y. So I'm going to take my equation and I'm going to substitute x with 2. So this would be 4. So -1/2 times 4 would be -2. Plus 2 times 2 is 4, minus 4. So, is that right? Okay, so -2 plus 4 is 2, minus 4, -2. Okay, all right, so I'm going to graph my vertex, because this is your vertex. H and K are your vertex. So 2, -2. Okay, and my y-intercept was -4, 2. So I know it's going to be passing through there. You can also graph your axis of symmetry. Axis of symmetry is the same thing as your H on your vertex. So my axis of symmetry is a vertical line passing through my vertex, right? Now I can predict, or not predict, but know that if this y-intercept is 2 units from my axis, I can go 2 units the other side and make a point because they are symmetrical. Okay, now x-intercepts, all right, I know my A is negative, so that means I'm going to be going down. So I want to have my graph looking like that. So am I going to have x-intercepts? No, it's never crossing this x-axis, right? And x-intercepts are points when they cross, so there's none. Okay? And if you were trying to solve this by factoring, you couldn't, because there's not a solution on it. Okay? All right, let's look at, let's see. Well, they don't have one that has x-intercept. Great. All right, well, let's just come up with one then. All right, let's just take this graph. Well, let me change my mind. Let's do this one. Because for x-intercepts, all you'd have to do is just factor and find your solutions. So let's look at this one. A is -1, B is 6, and C is -12. All right, so I need to find my vertex, my H and K. So my axis of symmetry will be opposite of B over 2A. So it's going to be -6 over -2, so 3. So that'll also be my x for my vertex coordinate. I know that A is negative, so it's going to be going down. So my vertex is going to be a maximum point. And my y-intercept is C. Okay. So -12, so that's going to be off the graph. So I can't mark that point. So let's find the y-coordinate from my vertex. So I'm going to plug in for my equation here. So negative x squared, and my x was 3, so negative 3 squared plus 6 times 3 minus 12. So negative 3 squared is 9, plus 6 times 3 is 18, minus 12. So negative 9 plus 18 is 9, and 9 minus 12 is negative 3. So that'll be my y. So we're going to graph our vertex, go to the right 3, and then down 3. So there's your vertex. And I do know that because A is negative, it's going to be going downward. So it's going to look something like that. But my y-intercept's going to be way down here off the graph because it's at negative 12. So I need to know some other points. So you can look at a table, okay? If I'm able to use my graphing calculator, the easiest thing for time purposes is to go into your graphing calculator under y equals and put in negative x squared plus 6x minus 12. And then you can look at your table and get some points. However, it may be that they give you a basic quadratic, that you're not looking at some really huge numbers, but a basic quadratic, and ask you this on the non-calculator part of your test. And again, you should know how to be able to plug in x's and find y. So what you're going to do after you've found your vertex here, you're going to take it and put it in the middle. So 3, negative 3, that's my x and y. That's my ordered pair, right? So I'm going to need some x values. So I'm just going to go backwards and then go forwards. That way I'm getting some points that are in the area around my vertex. All right? So if I plug in 1 for x, so it'd be negative 1 squared plus 6 times 1 minus 12. So it'd be negative 1 plus 6 minus 12. So that'd be negative 7. Okay. And then if I plug in 2 and replace x with that, it'd be negative 4 plus 12 minus 12. So it'd be negative 4. Now, since we know that our axis of symmetry is here, all right? And let me erase this imaginary that I made. This was our vertex. Okay, I know that if I graph these points, I got 3, negative 3, and then 2, negative 4 would be here, and 1, negative 7 would be here. So since it's symmetrical, if this is 1 unit from the axis of symmetry, I can go 1 unit over and make another point. This is 2 units, so I'm going to go 2 units on the other side. Okay, so now I've got a graph. So if I was to plug in 4, then I'm going to get negative 4. If I plug in 5, I'm going to get negative 7. Because if you notice, these are the same. If you remember back when we were doing the function tables, back in Unit 3, where we were looking at the characteristics of a function and identifying the type of function. And we were looking at the second difference for quadratic, that I told you that this is a turning point, all right? And I said it's called your vertex and that we would be getting to that. Well, here we are. So if you look, it's going from -7 to -4 to -3. So here it's going up to this point, and then it turns and starts going back down, -4, -7. So then at that turning point, your vertex, it changes direction, all right? But it is symmetrical. You have that axis of symmetry, so that this side is a reflection to this side. So that's why these numbers are identical. Okay. All right, so x-intercepts. Again, we're not crossing the x-axis, so there's none. If we were crossing, so like if this was upward and I needed my x-intercepts, then you would take the equation and you would factor and find your roots. Okay? All right. I do suggest that you watch the other video, graphing quadratics, and it will go kind of more in depth on looking at the table and graphing that way. All right, but I wanted to tie together all of the different points, and I also wanted to mention that C is always your y-intercept. All right, have a good day.